Hey, Paul, this is Mike. So I'm making this video for you. I'm going to go over a couple things, basically finish what we were talking about here, um, and I'll bring up this list here that I made. So first thing I'm going to do, explain basic memory allocation process of Java Virtual Machine, which is what we were doing before over here. And then after that, I'm going to show you how to access the Java API if you don't know how to already, to use the library of classes, and we can use that to do this task here to finish this, or at least get started on this task here. Okay, so I'm going to start straight from the beginning here. One of the things to know about Java is that it compiles and it executes line by line. So when we go ahead and we call this main function when we start the program, then this main function gets loaded into the stack memory. Again, there are two memory locations primarily when your Java virtual machine is running. You have the stack memory, and then you also have heap memory. The stack memory is where the logic and the variables that have been declared inside of your function. For example, we've got here's our main function called main, right? Or method, as you would say. And inside of this main method, we have a couple things declared here. We have this declaration of a variable called numbers, and that variable has been specified to hold the memory location of an array of int data types. So that is going to be stored in here. This for int, this I here that we declare and we assign a value to and create, that's also going to be stored in here. So we'll walk through this, and yeah, you'll see how this works. So, okay, let's keep going. So we'll start off by just walking through and getting back to where we were previously. I'll use a different color here. Let's we'll use black. Okay, so let's start at the top here. So we know that we're running this main method, right? We've got it here. First thing that is declared, or the first statement that's executed here is right here, this int numbers, and then you've got the two box quotes there, and then numbers declaration. So what that does is, like I said, it declares a variable numbers that's going to hold the memory location of an array of int data types. So what I'm going to do is write this here. I'm just going to use a shorthand. I'm going to write num. Okay. Then I'm put equals here, and you'll see why in a sec. So right now we just executed this line of code, and then this variable is going to be stored in this in the stack memory, in the main method here. Okay, so we go to the next line of code. We've got numbers, and then we use the assignment operator here, and then it says we're creating a new object, in this case an array of int data types, and it's going to be 1,000. It's going to be 1,000 units long, you could say. It's going to be able to hold 1,000 int data type values. So let's go ahead. Whatever happens over here happens first, it always goes from right to left. So this section of code is going to get executed first, and then the assignment will take place. So it's going to create a new array, and I'll write that here. So this is our array that's going to be created. Now obviously I can't draw 1,000 things, lines here, but if you can imagine, put like dot dot dot, and then here's our 1,000th one. So now, like I was saying, each of these boxes is able to hold an int value. So what that means is that in the programming language in Java, this int data type, int, has been specified to be up to 4 bytes long. So what that means is that each of these blocks of memory are going to be 4 bytes long. And what the computer has to do is go into this big area of memory here, this heap memory location, and it has to say, okay, I need to find 1,000 free memory locations, but they all need to be consecutive with each other. That's one of the special things about an array, is that all these memory locations are consecutive with each other in memory. So it goes ahead, looks for that, and it finds it, and then it separates. So this is 4 bytes, 4 bytes, 4 bytes. So obviously if you had 1,000 of those, that would be 4,000 bytes. So that's how much memory is currently being allocated right now for this array. So now let's go ahead and talk about this second part here. So we created this, right? We executed this part of the statement. We created the new array of 1,000 4-byte boxes, if you want to call it that, to hold int values. And now we're going to assign a value here to this numbers variable. Now the value that's going to be assigned here is going to be the memory location of this, and it's going to be the first memory location of this array. So what I'm going to say is I'm going to say, okay, like I was saying before, let's say this memory location here, let's say the memory location is A7. So now what's going to happen is this value A7 is going to get stored in this variable numbers. Again, I have the shorthand here. So whenever this numbers variable shows up in our code here, what it's really saying is, all it's saying is A7, which is pointing to this array right here. This is called, sometimes these variables are called pointers. The reason being is that they point to a specific area in memory. So that's an important term to remember. So this numbers right now is acting as a pointer to this array location. And we'll see this in some other instances as well, where there are more pointers. So let's keep going. So we just executed this line of code. Here again I'm saying, oh, numbers now is really equal to A7, like that's actually what the value that's stored in this numbers variable is. Okay, so now we get to our for loop. Reason for doing that is so we did this first part here. We created an array of length 1,000 that will hold integer values, okay? And now we want to randomly populate that array with values from 1 to 10. Okay. Before we get to that, because I want that to be part of the challenge here for you, something to work on. What I want to do is talk about the instantiation process. Like I was saying, there's 3 steps to the creation or to using a variable in Java. You have the declaration step, the creation step, and then the instantiation step. And sometimes these can happen all at once in one line of code, or they can take 3 lines of code like we have here, or 3 statements. So let's go ahead, let's look at this for loop now. Okay, so you're familiar with for loops, I think, from what you told me, and so you know how they work. So right now, let's look at this first part here. So I have int I is equal to 0. So what that means is I'm going to take a variable I. Now, real quick, here's an example of declaration, creation, and instantiation all in one go. Another way I could write this, let's say this is just for an example. I could write int I. Here's my declaration, right? So I just declared the variable. Now, essentially what I've said is, okay, give me some space in memory. In this case, it'll be in the stack memory because it's a local variable. It's declared inside of this main variable here. Inside of this main method here. Since it's declared inside, it's going to be a local variable and it's going to be found in the stack memory. So that would be our declaration. So it's basically saying, give me a memory location that can hold an int value. So essentially it's saying, give me a memory location that'll be 4 bytes and that will only accept a number, right? So okay, so that would be our declaration step. Next step is creation. So creation in this case is going to happen simultaneously with instantiation. So if I say I is equal to 0, what I've done now is, okay, now I've actually created this space in memory, and what it's going to do is it creates a space here, just like it would look over here. I'm not going to draw a box for it, but it's essentially the same. So I'm going to draw I here. There's I. I'm going to say, okay, and I is equal to. In this case, I'm saying I want to take this number 0, and I want to assign it to the memory location that is defined by I here. So, in this case, I'm going to say, okay, I'm going to take 0 and I'm going to put it in this memory location here. So right now we've got I equals 0. If I went down, another way you can think about it is, okay, here's my variable I, right? And what I is really doing is I is pointing to a space in memory. Let's say this is the space in memory. And let's say this memory location is, in this case, we'll say B2. Just for, just as an example. So it's going to point to a memory location called B2. And now over here I said I want to put 0 in that memory location. So it's going to take the value 0 and it's going to put it in there. So really what's happening when you when I reference I, let's say if I use it in here, right, it's saying, okay, I want you to go look at, in this case, I is going to have a value of B2, right? So once you see, when the computer sees this I, it's going to say, okay, really what it says is go to memory location B2. So that's what it'll do. Say, okay, I'm going to go look in B2. Now here's B2. And now it's going to say, okay, and now it wants me to get whatever the value of B2 is. In this case, it's 0. Now, let's say there was nothing inside of it, that it hadn't been instantiated. Then you might get an error saying, there's nothing inside of B2. I can't access that for what you want me to do. Like, let's say you had to add, you wanted to add like I plus 1. Or I plus r, and let's say r had a value of 2, but if this has a value of nothing, like as in no value whatsoever, they call that like empty set or null, then this can't be done. It's kind of like if you were to do a math problem, right? And you would say, what's 2 plus, and then you didn't just left that. You say, well, what's that equal to? Well, there's no way to answer that because you don't know what this is. There is nothing there to add to, so there's no way for you to come up with an answer, which is essentially what I'm getting at over here. Let's say, if this B2 was just completely empty, now I can't do this simple addition problem because there's no number to use. So hopefully that wasn't too much of a rant there, but so let's keep going. So now I just did in these two statements here, I can do this all in one statement. I declared it right here, int I, so this declaration happens, and then I also am going to create it and assign a value to it. Another word for that is instantiation, when you first assign a value to something. So in this case, I'm assigning 0. So going back to this, we have I with the value of 0 here. I didn't want to have to write all this out because that would be too much, but I think you understand what's going on. So we'll keep going. So we got int I is equal to 0. We have that here. Now let's look at this next portion. We've got I is less than numbers.length. Okay, so we talked about this before. This is, as you know, a conditional statement. This is the statement that says, if this statement has to be true for us to go inside the loop and execute this, right? So let's say this is the first time executing it, I is going to be equal to 0, right? So I've got 0 is less than numbers.length, and I'm wondering, is that true? Well, numbers.length, like I was telling you, is actually it's a field of an object, and we can get into that in a sec. Now with arrays it's a little bit different because some of the stuff is not that explicit, and I'll kind of explain that later. But at any rate, if you use, when I say numbers, right, I'm referring to this right here, right? Numbers has the value A7. A7 is this first memory location right here. And now it's asking, when I put dot length here, it's saying, okay, this specific array, how long is it? We know it's 1,000 because that's what we created it to be, right? So this is really saying, and I can just put this up here, this is saying, is 0 less than 1,000? It's asking that question. Well, in this case, yes, it is, of course. So that means now we can go inside of this loop and we can execute this statement. So let's keep going. And let's do something like this. Make it look like it's not another less than or something like that. Okay, so so we got to this part here. Now we're inside the loop. Now I've got numbers and then I here, right? Okay, well, again, like I said, I is another memory location, and it's referencing what's inside of I. Well, we know inside I right now is 0. So this is saying numbers at index 0. Now, I'm sure you may know this, but each, I'll use a different color here, each array location has a different index. This has an index of 0, 1, 2, keep going, and right now this would have an index of 999. So that's basically, it just counts it, and you're able to access the exact one that you want. So if I had numbers dot 867, I would go to the index here, which is 867, and it would show me, or it would ask, I would be able to see like what is inside of this here, right? Okay, so in this case, let's look at this entire thing. I'll put some comments here. Okay, so we've got numbers I. Right now, we know I is equal to 0, right? Let me do this. So we've got I is equal to 0. So therefore, it's asking me, and let's do this. So what is the array value at index 0? That's what it's saying, or it's basically saying, let's look in array value at index 0. Okay. So, and like I was saying before, whenever we have statements like this, you always want to read like right to left in this respect, right? So let's go here. What's I here? Well, we know I is equal to 0, right? Let's check over here. I is equal to 0, so I know this is 0. So right now, what I have is, I've got, so I've got the array location at index 0. And now it wants me to put in, so let me do it this way, using this assignment operator here, right? It's saying, I want you to put in whatever the value of I is, right? And in this case, each time it's going like this, it's saying, okay, well, I know I has a value of B2, right? So then it says, well, let's go to memory location B2. What's inside B2? It's 0. So now this is 0. So really what this is saying is, it wants you to put numbers in space I. It wants you to put 0. Let me put that, so numbers I 0. So now it's saying, sorry, numbers at 0. It wants you to put 0 in there. Okay, so that would be the execution of that. So let's go ahead and do that over here. And I'll use, why don't we use green? Why not? Okay, so that means I'm going to put 0 in there because that's what it's telling me to do, right? Okay, now we're going to go up here. I++. This is your post, after you go into your loop, this is your post for loop statement. Now sometimes this can just be blank, it doesn't have to be anything here. In this case, I'm saying after the loop is done, I want to increase I. Now this is just shorthand. And let me just put a comment here. So I++ is the same thing as saying I want to take I and I want to add 1 to it. Okay, now, again, like I said, you always have to look starting on the right side of the code. So if I looked at this code, so I've got I plus 1, right? Let's go down here. Okay, so the first part here is I have I plus 1. So now let's look at this. Right now we have I is equal to memory location B2, right? So I'm going to go to memory location B2, which is here, and it's got the value 0 in it, right? So it's basically saying, well, let's pluck that value out. That's really what it's asking for. So now I've got 0 plus 1, right? What's 0 plus 1? Well, we both know it's 1, right? So now I've got the number 1 here. And now it's saying I equal to 1. So it's saying take this 1 here, right? What this means is take this value 1 and assign it to memory location B2, right? We said the memory location right here is really B2. So what it's saying is now take the value 1 and put it in here. So I use my eraser and hopefully this works. Perfect. So now I'm going to take this value of 1 and I'm going to put it inside here. And that executes this line of code. Now this is the same thing. This is just a shorthand notation for it. And note that in this case, you don't have to put a semicolon at the end to execute this statement. That's just the syntax of the for loop, which I'm sure you've done before. Okay, so let's go back to here. So now, like I said, oh, come on, stop this. No, yeah, that's fine. Great, I don't care. Okay, thank you. Hello? Just unpin the tabs. Okay. Let's do this. Okay, I'm here. Let's go to document editor. What? Looks like it doesn't like this. Alright, I'm going to go ahead, exit out of this, and I'll finish this video in a sec.